Hey there, welcome back to our channel. If you're new here, don't forget to hit that subscribe button and ring the bell for notifications on the latest in data science and machine learning. Today, we're diving into a fundamental topic in the world of data analysis, k-means clustering. So, what exactly is k-means clustering, and why is it so important in data science? Let's jump right in. But first, let me ask you this. Have you ever wondered how companies like Netflix or Spotify recommend movies and music tailored just for you? The answer often lies in techniques like k-means clustering. So, what is k-means clustering, and how does it work? Let's break it down. K-means clustering is a type of unsupervised learning, which means that it doesn't require labeled data to operate. Instead, it helps us find patterns and group data points into clusters based on their similarities. But how does it do that? Let's explore the process step by step. Imagine you have a data set of different fruits and you want to group them based on their characteristics like color, size, and sweetness. Here's how k-means clustering comes into play. 1. Choosing k. The first step is to decide how many clusters, or groups, you want to create. Let's say you choose k equals 3, which means you want to group your fruits into 3 categories. 2. Initialization. Next, k-means randomly select k data points as the initial centroids, which are the center points of each cluster. Think of these centroids as the representatives of each group. 3. Assignment. Now, the algorithm assigns each data point to the nearest centroid based on a distance metric, usually the Euclidean distance. So, if you have an apple, a banana, and a cherry, the algorithm will determine which centroid is closest to each fruit based on their characteristics. For update, after all data points have been assigned to clusters, the algorithm recalculates the centroids by taking the average of all the points in each cluster. This new position reflects the center of the group data. 5. Repeat. Steps 3 and 4 are repeated until the centroids no longer change significantly, meaning the algorithm has found stable clusters. This is known as convergence. Let's visualize this with a simple example. Suppose we plotted our fruits on a graph based on 2 features, sweetness and size. Initially, the centroids might be randomly placed. After a few iterations, the apples might cluster together in one area, bananas in another, and cherries in yet another. But it's not just fruits that benefit from k-means clustering. It's used in various real-world applications. For instance, customer segmentation. Businesses can analyze customer data to identify distinct groups of consumers based on purchasing behavior. This helps them tailor marketing strategies and improve customer satisfaction. Image compression. K-means can reduce the number of colors in an image, helping to lower file sizes. By clustering similar colors, it allows for effective image compression without sacrificing quality. Anomaly detection. In cybersecurity, k-means clustering can help identify unusual patterns in network traffic that may indicate a security breach. Now, one critical point to note is that k-means clustering has some limitations. The algorithm assumes that clusters are spherical and evenly sized, which may not always be the case. Additionally, selecting the right value for k can be challenging. Using techniques like the elbow method can help determine the optimal number of clusters by plotting the explained variance as a function of k and looking for an elbow point where the rate of decrease sharply changes. Also, k-means is sensitive to outliers. A few extreme values can skew the centroid position, leading to misleading clusters. Therefore, pre-processing your data by scaling or removing outliers can improve the clustering outcome. To wrap it up, k-means clustering is a powerful tool in a data scientist's toolkit, allowing us to uncover patterns and group similar data points without needing labeled information. Whether you're analyzing customer behavior, compressing images, or detecting anomalies, k-means can provide valuable insights. So, next time you enjoy personalized recommendations or see a beautifully compressed image, remember that k-means clustering might be working behind the scenes. If you found this video helpful, please give it a thumbs up, share it with your friends, and leave a comment below if you have any questions or topics you'd like us to cover next. Don't forget to subscribe for more educational content, and until next time, keep exploring the amazing world of data science.